Okay, so welcome to the fourth session, Logistic Regression and Regression tree analysis. So for the logistic regression, we examine how we can develop algorithm to predict qualitative outcome. For example, male versus female, purchase versus not purchase, tumor is benign versus malignant. So this is like categorical values, yes and no, buy or not buy. So this classification problem is best modeled with the probabilities that are bound by 0 and 1 because we have two values, right? So 0 and 1. So this is a special case of regression analysis. This is calculated when the dependent variable is nominal or ordinal value. So meaning that you have label or categorical values. Dichotomous variable 0 or 1 can be predicted by using a logistic regression. So the probability of occurrence of characteristic 1 is estimated. For example, like this, we are using age, gender, smoking status as the independent variable to predict the dependent variable in which, in this case, disease, yes or no. So last time in the multiple linear regression, your dependent variable are all in numerical value, but for this one, they are in categorical value. They are label values. Okay. Because when we have categorical value, we will have a graph something like this. So if we use the linear regression, the graph will show something like this, in which you will have a value between plus and minus infinity. Let me place my pen. So you could have plus infinity or minus infinity here. So we cannot describe the data that we have here because your data now is between 0 or 1. Okay, buy or not buy. So we cannot use linear regression here. So the goal of logistic regression is to estimate the probability of occurrence, not the value of the variable itself. We are not trying to predict the value of the variable, but we want to predict the probability of occurrence, 0 or 1. Okay, so the range of value for this prediction is thus restricted within this 0 and 1 only. So to ensure that we have this value, we have to use the logistic function. Okay. So what is logistic function? So the logistic function is described here, in which whatever value we have for the x here, so they are described by this formula, 1 divided by 1 plus epsilon to the power of minus z, where the z here we substitute with the linear regression that we have, linear formula that we have. Okay. So this is the formula that we will try to estimate. So whatever value we plug in for the x1 up to xk, the value will remain between 0 to 1. Okay, so that's why we use the logistic function. So that's why they're called logistic regression. Okay. So let's take a look how we can use this one in trying to predict or learn some of the data. So this is the Titanic dataset. Have you seen the movie Titanic dataset? So some survive and some not survive. So what they wanted to do here is that they want to know what determine the survival of the person that was involved in the Titanic tragedy. So they have the passenger ID, and then this one will indicate whether they survive or not survive. This is the class number. This is the name, gender, age, number of sibling, um, and so on. The ticket number, the fare, which cabin, and then which station that they um, embark. Okay? So this is the description that we have. So we wanted to model this one, survival, because the survival is no or yes, and we have all these variable that we have. Okay, so this is port of embarkment is where they like the couple from Queenstown, Southampton, and Charlesbourg. Okay, so the first thing that we perform here is that we are reading the file from this data that we have, and yes, the data has a header. So the first row will be the name of the each column. Okay, so for this one, we will eliminate all those that have a blank space. Okay. For your information in data mining or knowledge discovery, most of the work that we have done involve data cleaning. 90% of our work, no, 80% of our work, we need to perform data cleaning. Okay, so we wanted to know whether our data is clean to be processed. So the first thing that we could do is we could apply this not applicable value, meaning that empty value. So we wanted to do for this data, and then we want to know how many of the cell that we have is empty. So this is the result that we have. We have around 171 row for the edges that empty. Maybe the data was not captured. The same thing goes here and above. So we have missing data here. And the second one is we want to know how many unique value that we have for each of the columns. So we apply the unique statement here, and then we want to know how many of them. Okay? So this will tell you the unique values that we have for each column. But the most important is this one. So we know that we need to fix the cabin and also the age and also the embark column. We could also use the Amelia library, use the mismap function. The mismap function will tell you which column will have missing data. So if we look at here, the cabin and also the age and also the embark, we have red because they are missing values. So we need to fix this one first. Okay. So how do we fix this one? For the age, we could take the average and then just get the average of the age as the default value. Okay. Okay. Since in trying to learn the data, also sometimes we can ignore some of the column. For example, passenger ID is not relevant. For example, student ID, employee ID, they are not relevant in learning your data. The name also has no uh, relation to the survival, um, and also the ticket, okay, and also the cabin number. Okay, so what we want to do is we want to select a subset of the data from the Titanic. So we only select number 2, number 3, number 5, number 6, 7, number of siblings. Uh, this one is number of parent. This is the fare, and this is where they embark. Okay. Okay. For the age here, we have missing around 177. So what we should do is we just replace with the average. There are many ways on how we can handle missing values. Um, that one will be you have to study on your own or in another level lah, advanced level. I would like to cover that one also if we have time. So one of the technique is to find the mean lah. So what happened here is that I'm focusing on the age, and then I'm looking at the um, mean where they are not missing. No, yeah. Um, I'm looking at the average age that I have in my data set. Okay, so whatever mean that I get, I will store and replace the one that is missing in my data set here. So this is simply a statement saying that I'm getting the average here, and then I will replace all the missing value here with the mean of the age that I have in my data set. Okay, and this is one of the way to check whether my column is a label or not label column. So we use the is factor. Okay. We could also look at the contrast of the categorical variable. So if we say contrast, this is our data frame and this is the column. Then we have 0, 1. Contrast for the embark, we have 3 station. So this is just to look into how our data looks like. Okay. Okay. If both this is 0, that means you embark from C station. If this is 1, that means you embark from Q. If this is 1, that means you embark from S. Okay, but if both 0, you embark from C. Remember last lecture when we use the dummy variable, we're supposed to have 3 columns, but 2 columns is enough already to describe 3 characteristics. Okay, so for the 2 value that is missing for the embark here, so we decide to remove them lah. So this one we will remove the one which is not applicable. Okay, and this is our new data. So this one saying that I will only take the data which is not missing for this particular column. So I will store them back into this data. And for this one, I will delete the row name, the row title. So I only need the data to be processed. Okay. So like the other classification algorithm, we have to divide our data into train and test data. So what happened here is that notice that we have two part here. So this is row. Okay, so this is column. So I'm taking row 1 up to 800 to store in the trend, and then row 801 up to 889 to be in my test. So I only have 89 data to be tested. Okay. So if the column is empty, meaning that I will take all the column. Okay. So this one I specify row 1 up to 800. Okay, to model our data, we use the GLM. So we are using the binomial because this is for the logistic function. So the data that I'll be using will be the trend data set here. Okay, so I will model the survive based on all the independent variables that I have in my data. Okay, so when I look at um, the summary of the model, we know that the the class type of the train and also the male and also the age will determine the survival of the passenger. Okay, so these are the three main variables. So like the number of siblings, the parents, pay, and where you come from are not significant. Okay, so how do we know the quality of model that we have? Okay, so what we can do is, okay, now we can use the test data set. Okay, so the test data set here. So I only select 2, 3, 4, 5, 6, 6, 7 without um, the charges, because if we look at our test data set here, okay, our test data set coming from data. So our data come from here. Okay, so we have all this. So when all this will be stored here, they will become 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I want to model my survive variable based on this. Okay, so I only take 2, 3, 4, 5, 6. So this is the the independent variable that we have. So this is your dependent. So that's why here, when you perform the training, I only take 2, 3, 4, 5, 6, 7, 8. Okay, because I want to get the result for the column number 1. So the type response here is that the value that I will be getting will be 0, between 0 to 1. Okay, so I use the predict function to predict the new instant here using the model that I have. The model that I have is based on this formula. Okay, so once I get the result, so I will convert my result. If the value is greater than 0.5, I will put 1. If below than 0.5, I put 0. Okay, and then I will match with the test survive column, and with this one, so I will take the mean lah, how many of them get correctly classified. So when I print this one, basically I will just get the accuracy lah. So the accuracy that I get is around 0.84. Okay, so this is how you use logistic regression in order to model a categorical value using a few independent variables. Okay. So any question?